Hey everyone, welcome back. Today we are beginning Unit 2A, which is all about congruent triangles. I think this unit's kind of fun. We get to start looking at some huge topics in geometry, like proving triangles are congruent. So let's go ahead and get started. The first thing we're talking about today is classifying triangles by their angles and their sides. This is, if you're following along in your book, Chapter 4, Section 1. First, let's talk about classifying them by their angles. This might seem familiar to you already. If it is, that's great. The first type of triangle that we have is an acute triangle. This is a triangle with all three angles are acute. Next, we have an equiangular triangle. This is a type of acute triangle where all three angles are congruent. Next, we have an obtuse triangle. This is a type of triangle that has one obtuse angle. And finally, we have a right triangle. We've definitely seen these before. This is the type of triangle that has one right angle in it. Let's do some practice together. It says classify the triangles by their angles. Classify it as acute, equiangular, obtuse, or right. So first, part A, I see these are all three acute angles. They're not all the same. That means this is an acute triangle. Next, part B, when I look, I see this 90-degree angle. I know that's a right angle, so this has to be a right triangle. Go ahead and try these practice problems on the right. The correct answers for part A is obtuse, because it has an obtuse angle here. And the correct answer for B is equiangular because all three angles have the same measure. Okay, let's do another one together. It says classify triangle PQR based on its angle measures. A triangle is always named by its three vertices. These are the 3 points that create the triangle. You can put them in any order. So this could also be called triangle PRQ or QPR. It doesn't really matter. But this is the triangle we are trying to identify here, is the one outlined in green. So let's see. I see that this angle P is 45 degrees. Angle R is 31 degrees. However, angle PQR, I'm going to have to use my angle addition postulate. So first, let me see what's the measure of angle PQR. I know that I would have to add up the measures 45 and 59 together to get the measure of angle PQR. I can already tell that that's greater than 90. So since it's greater than 90, I know that triangle PQR is an obtuse triangle. Now let's talk about classifying triangles based on their sides. There's 3 different classifications for triangles based on their sides. The first is called equilateral. This is when all 3 sides are congruent. Next is an isosceles triangle. This is when at least 2 sides are congruent. So therefore, an equilateral triangle is also an isosceles triangle, because an equilateral triangle has at least 2 congruent sides. And finally, we have a scalene triangle. This is when no sides are congruent. I think some of you may be beginning to drive, so you might recognize this picture in example 3. It says classify the triangle by its sides. In your car, you might have seen this button. It's the emergency button that you hit to make your flashers come on in your car. I see that all 3 sides have the same measure, so I would classify this as an equilateral triangle. Let's try another one. It says point M is the midpoint of segment JL. Classify triangle JKM. That would be this one. As equilateral, isosceles, or scalene. Explain your reasoning. Now let's look closely. It told me point M is the midpoint of segment JL. Here's point M. If it's the midpoint of segment JL, that means that it splits segment JL into two congruent pieces. That means that these two segments are congruent. Now I also have the measure of segment JL, so I can go ahead and find the measure of segment JM. I know JM would be equal to half of segment JL. In other words, half of 1.5. So I know the measure of segment JM is 0.75. So let's fill that into my diagram. Now if segment JM is congruent to segment KM, KM would also have to be 0.75. If I look at triangle JKM, I see that all three measures are 0.75, so I know that this triangle is an equilateral triangle. And in order to explain your reasoning, you could talk about the midpoint theorem, saying that the two segments JM and ML must be congruent, and talk about the transitive property, why segment KM is also 0.75, and then the definition of equilateral triangle gives us our answer. Let's do this final question together, this example 5. Find the measures of the sides of isosceles triangle ABC. Isosceles triangle means that at least two sides are congruent. I see that side AC and CB are marked as congruent. That means that I could set their measures equal. Next, let's solve this equation. So first, I'll subtract 4x on both sides. And I'll also go ahead and add 0.5 on both sides. So that gets me 1.5 equals 1x. Now I don't really need to write the 1 there. If you did, you know that 1x is the same as x. So I know x is equal to 1.5. But I didn't want to find x, I wanted to find the measures of the sides. So let's go ahead and find the measures of the sides. I know that AC is equal to 4 times x plus 1. I know x is 1.5, so we can use substitution to plug in 1.5 for x. Now 4 times 1.5, that gives me 6. 6 plus 1 is 7. So I know AC equals 7. Now I don't really need to plug in the measure for BC. BC is going to be easy to find because I know it's congruent to AC. If you wanted to check your work and plug in 1.5 again for CB as well, you could and make sure you get 7, but only if you have extra time. Finally, let's find AB by plugging in 1.5 for x. So we have 9 times 1.5 minus 1. First, do 9 times 1.5 to get 13.5. And then subtract 1 from that, you get 12.5. All right, finally for today, I'd like you to reflect on this question. An equilateral triangle has sides that measure 5x plus 3 units and 7x minus 5 units. What is the perimeter of the triangle? Explain your answer in 1 to 2 complete sentences. All right, I'll talk to you tomorrow. Tomorrow we'll be back to learn more about goals 2 and 3, which is more stuff about triangles. Talk to you then.